Okay, so in 9.1 we learned how to graph a point. Well, graph an infinite number of points, put them next to each other, you form graphs, right? So the next logical step will be to graph polar equations. All right, so here's some classic curves, some kind of weird little graphs you can get from polar equations. Okay, the first one. Now your responsibilities in this section, right, will be to be able to identify the name of the curve by the equation or by the graph. All right, so identify the name, so be identify the equation and the graph. And the second piece will be given an equation, actually be able to graph it. So if I gave you an equation, you could make these graphs, right? All right, we'll just do that on the calculator. Okay, the first one's called a rose. All right, polar coordinates, it's always going to be r equals, just like in rectangular was y equals, but polar is r equals. So it's going to be some number, just a, times cosine, and then the n here it says a positive integer. Right? And an integer is pretty much a whole number that can go into negatives and positives, right? -1, -2, -3, and then 1, 2, 3, 4, all that good stuff. So this says specifically it's a positive integer. So you're looking at the ends can only be 1, 2, 3, 4, on and on, right? No fractions, no decimals, no radicals, none of that stuff. Okay? So I can do sine or cosine. It's just going to be something, some number, right? A can be anything, positive, negative, fraction, times sine of an integer, a positive integer, times theta. All right? Once you get that, or when you graph it, you'll get a graph that looks kind of like a rose. It has these little petals. All right? And there can only be, or the minimum number of petals will be 3 for a rose. All right? Okay. So, and you can go on to however many. There could be 100 petals, depending on how large your n is here. All right? Now, phonetically, these words are spelled below so you can pronounce them. This is a lemniscut. All right? So a lemniscut has a square term. That's the only equation you'll see with squares. So, same kind of thing. It's a number squared, right? Cosine of 2 theta. So if you see any square, some number out front, cosine 2 theta, sine 2 theta, you know you have a lemniscut. Okay, now a lemniscut's kind of like a rose, but it has 2 petals. All right, so 2 petals. And that's why the rose has to have 3 or more, because if it had 2, it would be a lemniscut. All right, and if you want to graph these, all right, to graph one, right, you would have to solve for r. To solve for r, just take the square root. All right, you notice when I took the square root, I have a plus or a minus. So if we zoom in, all right. So now you have 2 equations. So to graph a lemniscut, you'll graph r equals square root whatever a squared cosine 2, and then you'll also graph r equals a negative square root. Blah, blah, blah. All right? And keep in mind, this plus minus is not inside the radical. They're outside. So graph a positive radical, then graph the exact same thing, but a negative radical. All right? So that's how you graph the square. So lemniscuts have squares. All right? Next one's a limuson. So I have an a plus b cosine, which means these 2 numbers are different. I'll have some number plus or minus another number times cosine. Now notice I said minus even though there's a plus here, because b could be negative. It could be any number, right? A and b can be anything. So this could be 1 plus 2 cosine or 1 minus 2 cosine. Makes no difference. But a and b have to be different. All right, cardioid. It's the same thing, except you'll see it's an a and an a. These 2 numbers have to be the same. So it's going to be r equals 1 plus 1 cosine. R equals 6 plus 6 cosine. R equals negative 2 minus 2 cosine. All right? Okay, now if you graph those, here's what you get. You get this shape for a limuson, which is kind of a butt shape for lack of a better term. Okay, and be careful, just because you see this kind of shape doesn't mean it's a limuson from a graph, because a cardioid could actually look just like that, right? And all of these could be turned upside down, left, right. So I just drew one of them, but it could be any direction. All right, because if a and b are close to one another, if I pick 1 here and 1.1, that's very close to 1 and 1 for this. That's why they're going to look the same. Right? The bigger the difference between a and b, the more different your limuson will look from your cardioid. Right? And in fact, the bigger the difference, you'll see this butt shape now has an actual kind of loop inside. So the bigger the difference, the bigger the loop will be. All right? Okay, your last one's spiral of Archimedes. I would recommend when you do these classical curves, you pretty much do them in degrees. Some graphs look better in radians, some in degrees. Mostly, though, it's degrees. When you get to the spiral, though, it has to be in radians. Your r has to be in radians. All right? It's just some number times theta. Okay, so let's graph a few of these. So let's try the first one. Okay, I want to graph r equals 1 minus 2 cosine. Well, to do that, first thing we have to do, hit mode and get out of, most of you should have function right now, so that FUNC. Alright, that's function, that's x and y, that's regular rectangular. I want to go to POL for polar. Alright, so now I'm in polar. So now you'll see once you hit y equals, you no longer have y equals, you have r equals. Alright, and if you hit the x, the button we used to hit for x, so the x, it says t, theta, n. If you hit that, now you'll see you get thetas. Alright, so I don't have the x's anymore because I'm in polar. I have r's and thetas. Alright, we'll graph it. Let's do 1 minus 2 cosine theta. Alright, so I just type it in just like it's written. Alright, these graphs are going to be different sizes, so I'd always do zoom, or the first one we try is zoom fit. So hit zoom 0 and see if it fits it to a nice little graph. Alright. Okay, now in this case, we don't see anything. My zoom fit didn't work very well. So I'm going to have to go back and hit zoom standard and see what I get. Alright, so then I get that picture. So zoom fit doesn't work, which on some calculators it works great, some it doesn't. I have no idea why. Well, I have that picture right there. Well, I want to kind of zoom in on it a little bit, so let's hit zoom. And now the first one is a box, so zoom 1. Alright, and then you'll see I have a cursor I can move around. Well, where I get it where I want, I hit enter. And then if I drag down, you'll see it gives me the height of my box. If I drag to the right, it gives me the width of my box. And I can change that at any time. Now when I hit enter, it'll just zoom in on that box. And then you'll see this is a great Limusan. Alright, Limusan's a dead giveaway because of the loop inside. And we could just hold that from the equation. Right? Limusans and cardioids are the only ones with pluses and minuses. So plus, or this is a minus 2 separate numbers, Limusan. Right? If they were the same number, it'd be a cardioid. So how would I graph this? For these, all I want you to do is make a quick sketch. So kind of come through, and then make your loop. Alright, so there's a Limusan. Alright, let's graph the next one. Here's a square term. Alright, only ones with squares are lemniscuts. Let's label. So I want you to graph and label. Remember, you have to identify these. The hardest part is probably pronounce them and spelling them. Well, here's a square, so I automatically know it's going to be a lemniscut. Alright. Well, what do I have to graph? This is going to be r equals plus or minus 3 sine 2 theta. Alright, so I have to graph the plus and the minus. So let's graph the plus, so square root of 3 sine 2 theta. And let's graph a negative, square root 3 sine 2 theta. Alright, if you don't do the negative, you only graph one, you get half of it. So you only get half the 2 petals, the 8. Alright, let's do zoom 6, because it doesn't seem like my zoom's working very well. And you'll see I get this little picture here. So let's do the same thing. Let's zoom box, see what we get. Alright, let's get a better picture of this thing. So down to get my height, right to get my width. Zoom in, and there you go. You'll see it's a nice little 2-petal graph, kind of tilted a little bit, right? So we'll graph a petal, and graph a petal. Alright, there's my lemniscut. Okay, now let's do system. Solve a system. So there's 2 ways I can solve a system. Alright, I can graph it, and the answer, right, is where they intersect, or I can solve it algebraically. Alright, so I'll do both. Let's try to graph first. Alright, so to graph a system, I want to graph the first one, r equals 2, and the second one, 1 plus sine theta. Alright, so let's see what these are going to be. The first one, r equals 2 in polar, is just a circle. So we expect to see a circle. And then 1 plus 1, right? These two are the same. This is a cardioid. I'm going to look at a cardioid or a circle and then another little butt-shaped one, right? Okay, so now when I do, let's go zoom 6. So there's my circle. It looks like there's my cardioid. Right? I'm going to zoom in a little bit. So let's go zoom box. Again, if you can hit zoom fit, if you want to play around with the zooms too, there's a zoom square. There's a lot of good zooms. Right. And then there's my circle. Here's my cardioid. You'll see that's the bud shape. It doesn't look like a circle because of the window. You'll see I'm stretched out. It's like a TV, right, or a movie screen. So if I squared it up, it would be a circle. Well, where does it look like they intersect? Right at the top here. So it's 1, 2 tick marks, right? It's the circle, so it's a 2 for radius. And now what's this angle? Here's the x-axis. It's 90 degrees. So from my graph, right, my solution looks like they intersect at 290. All right. Well, how would I do it algebraically? I have two equations to solve it algebraically. I want to substitute one into the other one. So substitute the 2 in, subtract 1, inverse both sides. So inverse of 1, 90 degrees. Alright, well I know that the r is 2, because that's part of it, told me r equals 2. And when I solve for the angle, I get 90. Alright, so you have a choice. You can either solve algebraically or you can graph them. Alright? Okay, now the last piece of the notes I'm not going to go through, but graph all of them. So pick a rows, just pick some numbers, graph the sine, graph the cosine, and just look at them. See what the similarity is, right? What do they have in common? What's the difference? Are they the same graph? Or is one rotated? How do they look? Alright? So, those are classical curves.